Okay, so here we're going to be using the change of base rule to solve a fairly tricky logarithm question. Now the change of base rule for logs is quite simple. If you have log base A of B, you can change the base and you can make the base be whatever you want. Okay, as long as they're the same for both the logarithms. Okay, you can see the B on the top comes here and the base A becomes the new log on the bottom, and you choose whatever base you want. So you can see the similarity between log base 2x and log base x2. So what I'm going to do is I'm going to use this just to change log x2. Okay, now if I do that, I can choose whatever base I want, but what we're going to do is we're going to choose the base to be very sensible. And the sensible base in this case would be base 2. And the reason that's sensible is, first of all, log 2 is 1. And the second reason that it's sensible, is that you have log base 2x here. So if you choose the same base as whatever this part of the question is, then you'll be able to collect the terms together. So I can rewrite this. The left-hand side stays the same, but this log x2 becomes 1 over log 2x. 5 over log 2x. And that's a really common trick that is required a lot of times, both at maths and SL level. Multiplied by log 2x. Log 2x squared minus 4 log 2x equals 5. Now, if you actually think about it, you have a quadratic here in log 2x. I have a squared term, I have the linear term, and I have the constant term. So that means I can factorise log 2x, log 2x. Your numbers have to multiply to give minus 5 and add to give minus 4. Therefore, I take minus 5 and I take plus 1. So log 2x equals 5 and log 2x equals negative 1. Raise them to the power, so to get x by itself, you do 2 to the power 5, which is 32. And here we'll do x is 2 to the minus 1, which is 1/2. And those are the two solutions. To check it, if you wanted to, you could put 32 and put 1/2 in the x here in your calculator and just make